Hello and good morning. Today we'll be reviewing another paper that I'll be linking to the description for this video. This is the Darwin-Gödel machine open-ended evaluation of self-improving agents. And this is also a very recent paper. It was published in the 29th of May. So this is sort of very topical and relevant subject here, which is self-improving models. And specifically self-improving agents. So this group essentially takes a base model, and usually if you're taking a base model and want to apply it for some specialized purpose, say coding for example, you would do you would build some scaffolding, some structure that would help improve the model's performance for this one particular application. And what they do is they give the model the ability to change its scaffolding, and they test it against the coding problems to tell whether these changes that the model made to itself improves its performance. And if it does, then it will adopt this new structure that it developed itself. So the idea here is really a recursive self-improvement. So you have a model that you release, and the model figures out how to improve its own abilities to perform the tasks that you give it as well as possible. So there are two kind of interesting things that I noticed from this paper. The first thing is that the way that they test different parameters and stuff, the performance of the model, is they track every searched pattern, like every searched parameter space for the model scaffolding. So if you, for example, you begin with a certain structure and you make some minor modifications, you get a new performance, but you maintain that old structure and that old performance in the memory of this improving algorithm, so that if you hit a dead end, you can go back, traverse back up to the tree, and start from another configuration and begin iterating on that to see if you can find improvement. So that's the first thing. That was a good idea that I picked up from this paper, and it makes sense. And the other very interesting thing that I got from this paper as well is that for recursive self-improvement, it's the same problem as any sort of intervention that does not rely on human data or human approval, and really, or human feedback. Really, the problem is that a model needs some way to verify that it is improving. So in the sense of coding, you can kind of get away with this. It's one of the traditional areas where you can do a lot of progress without explicitly relying on any human signal. And the reason is that if the code fails, then you know it failed. So it's easy to verify that you are improving. You can have a benchmark of questions, and you make some changes, and the model does something, and lo and behold, you're now answering more of the questions, so you know you're moving, or you have an idea that you're moving in the right direction. So the same also holds true for self-recursive improvement, which is you can only recursively self-improve if the model knows that what it's doing is good, that this new configuration is better than the old configuration. So if we're thinking in terms of where things are likely to evolve with this field, it will probably be self-recursion applied to problems that are easily verifiable. So for example, coding problems. So I definitely see, they have already demonstrated really impressive results with a coding model that just recursively self-improves. And I'm certain that all the big AI frontier labs are also working on the same thing, and it's probably rather successful. This is, I would expect, what is driving progress in coding models right now is this sort of improvement that happens, probably assisted by the models themselves, to improve their performance, their coding performance. So that's pretty much it. It's a very interesting subject. a lot of people are very fascinated by this because the point at which you get a self-improving algorithm that is robust, that is effective, then you are close to a point where uh, like models will drive their own development, and that will accelerate the rate of progress enormously. So that's pretty much it. I hope that you enjoyed, and I'll talk to you guys again tomorrow. Bye.